Okay, in this video, I'm going to be demonstrating the design and build of my robot for the Fundamentals of Mechatronics and Robotics 2 module. In this clip, I'm just demonstrating what I've been sent from university. Now, the design of my robot is based off the Janssen mechanism, which consists of a bunch of linkages, which is fixed onto a rotating point, either on a wheel or a gear, so that once it rotates, it creates a crawling-like motion. Now, when we fix two linkages onto the same point, the robot will start to walk.
Here you can see I've come up with a design for the main body, and I've chosen to attach my leg onto a fixed point onto a gear. This gear is then driven by a main gear attached to the servo motor, so once it rotates, the leg moves back and forward, resulting in the robot moving forward. I then began to draw out some measurements for the components of the legs. This was important as it ensured that once the robot was assembled, the leg would move in the proper motion of dragging its foot along the ground.
Here you can see that I've used the cosine rule and the sine rule to come up with some angles to create the linkages. I also came up with a quick design for the gears, where I came up with some dimensions for the inner circle, the outer circle, and a pitch circle. I also came up with some dimensions for the tooth pitch and distance. Now that I'd decided upon a design, I then headed over to Solidworks to begin designing the robot so that I could then put it together. In this section, I'm designing the lower leg of the mechanism. I then created a main body for the robot where I would house all the electronics, such as the sonar sensor in the front and the servo motors in the side. I left a small area on top, including two holes so that I could fit the wires through for the servo motors. Once I had designed all the parts on SolidWorks, I then put together this animation which shows the full assembly of the robot after the lid's been put on to cover the electronics. I then created another animation that would demonstrate how the robot would walk forward once all the parts were assembled. I then hooked my computer up to a 3D printer so that I could begin printing the legs in a black PLA plastic. Whilst waiting for the legs to print, I then headed into the garage to start sawing down some screws to an appropriate length. You can see that I printed the legs as a full set to save on time. I was using Ultimaker Cura to 3D print my parts. In this section, I'm setting up the orientation from the main body of the robot. Whilst this was printing, I thought it'd be a good idea to alter the servo motors. At the moment, they only rotate 180 degrees. We want to look at taking it apart and removing this small pin on the second to top gear at the top, just here. We also want to remove this small electronic circuit just in the bottom of the servo motor. Now there's a small green potentiometer that we need to get rid of for the servo to rotate continuously. To remove this, we just want to look at soldering it off. Now to replace the potentiometer, I'm using two 2.5k ohm resistors and soldering them together to make a voltage divider. We just want to solder this back onto the circuit board where the potentiometer was. Then from here we can start putting the servo motor back together and assembling the compound gear train at the top. I'd previously worked with the sonar sensor on Arduino to detect distance, therefore I just connected it to a small circuit with both servos, just demonstrating that they both now continuously rotate clockwise and anti-clockwise. Now that most of the components had been printed, I then began to play around with how the leg mechanism would move. The main body of my robot had finished printing, and now I could begin to group together all the components so that I could begin the assembly. This is what the robot looks like now that I've finished assembling all the components. You can see in this clip that the robot's fitted with all the electronics, but I have to hold the cardboard underneath it because the robot doesn't walk on its own as I intended it to. Now, one of the main issues is the balance of the robot, so if I was to do this differently, I would add more legs, or I would just increase the surface area of the leg where it comes in contact with the ground. Another issue is that the main body that I'd designed is just too heavy for the robot, therefore it struggles to keep its balance when moving forward and sometimes topples over.